Welcome everyone. This video is to present an executive summary of ATLANTES, quality control of carbon parts based on machine vision. My name is Francesca Canale and I will guide you through this video. This solution is developed in TRINITY Demonstration Program 2, where one of the goals is to improve the agility of European SMEs in the manufacturing industry. After a short introduction to the partners of the project, in this video you will learn about our use case and the results that we achieved. Finally, I will present the conclusions and the links to follow to get more information about this use case and the EU project Trinity. This use case is presented by Trinity SME partner STAM, which is located in Genoa in Italy. Other partners are Visca Automation Systems, based in Cork in Ireland, and Composite Industries, based in Zalău in Romania. STAM is the consortium leader and is an engineering SME with expertise in near-infrared hyperspectral imaging. Visca is an SME specialized in machine vision and high-accuracy manufacturing systems, while Composite Industries is a small manufacturer of CFRP components and in Atlantes plays the role of end-user. The purpose of Trinity Project Atlantes is to automate the quality inspection process of CFRP components production lines by deploying a machine vision system based on both a traditional RGB camera and the near-infrared hyperspectral one. The RGB inspection is based on an acquisition system ideated by the project partner Visca, able to capture high-resolution RGB images of uncoated carbon fiber parts. The images are then analyzed by the neural network of the object classification module provided by Trinity for the classification of different types of common defects. The second acquisition system is based on a near-infrared hyperspectral camera placed above a conveyor belt on which the part is placed. By analyzing the spectrum in the near-infrared range of wavelengths, it is possible to differentiate the spectral pattern of pixels belonging to a defective area, highlighted in red in this slide, from the pattern of pixels belonging to a regular area, which are instead highlighted in green. Following these considerations, it was possible to develop an automatic algorithm to discriminate defective areas from regular ones. The main result achieved with Atlantes is the successful detection of different types of defects by exploiting both machine vision systems. The outcome of the investigation delivered specific improvements over human-based visual inspection, including the ability to detect pitting, wave, and surface matte defects at higher resolution beyond the visibility of humans. All three types of defects can be made visible in captured images, with an inspection accuracy of 87% on average, providing significant improvements over human-based inspections. To summarize, thanks to Atlantes, it is possible to increase the agility level of the production line and the productivity, reducing the process time. Also, the quality of the process is increased, being able to detect smaller defects with better accuracy. Moreover, now it is possible to store images of various parts to have an electronic record of the parts produced. The process is also less expensive because less human labor is wasted in the visual quality inspection, and social benefits are also achieved thanks to the reduction of mental workload and stress for operators. In this project, the CFRP components manufacturing sector was chosen as application scenario. However, the Atlantes approach can also be exploited by other manufacturing sectors, characterized by low volume and high diversity production, and it can address the need to speed up the quality inspection process of products. The support of the Trinity project has been fundamental to complete this demonstration. First of all, it was thanks to Trinity financial support that the development of Atlantes inspection system was possible. Moreover, they helped us also with the dissemination of Atlantes, allowing us to participate to public events such as the European Robotic Forum. Also, the mentoring service provided by Trinity was helpful for technical and administrative issues. To conclude, the purpose of this use case was to deploy a machine vision system for the automatic quality inspection of CFRP components. To have more information, you can also visit the Trinity catalog by scanning this QR code. If you are interested and would like to find out more, contact us and follow us on our social media channels. Thank you for watching this Trinity use case executive summary. Goodbye.